Am I audible today? Thank you. We will start in a minute. Okay, let's start it. When people come, they will join. So, hello everyone. Welcome to this GATE NPTEL lecture course. So, today we are going to discuss polarization in electromagnetic waves. This concept is very much have weightage in GATE examinations. For example, in GATE 2019, there are two questions from this concept and one in GATE 2018, then GATE 2015 and GATE 2013. So we are going to discuss these questions in today's lecture. In the first question, we have to find what is the direction, what is the electric field wave that is coming. For example, the electric field of an electromagnetic wave is given to us, and what is the resultant wave after the combination of these field. Similarly, in the second questions, we have given a combination of polarizations and we have to find what is the resultant intensity after this combination of polarizations. And in third questions, the light in this question, the electric field is passes through quarter wave plate. There is this element. We will learn about this. And what will be the light after passing through this quarter wave plate. So these are the type of questions that we will going to face in GATE exam. So let's start it with this electromagnetic wave concept. So what is wave? It is a continuous disturbance in a medium which propagates in fixed shape and at constant velocity. For example, if you take a string and you just take it up and down, it will start. There will some disturbance created by you, and it will start away, moving away from you. And this kind of disturbance, which is moving in string, is known as waves. So mathematically, it is the solution of this wave equations. So this is the wave equation and the disturbance that you have created. This disturbance is the solution of this wave equation. So generally, the solution of this wave equation has the form f function f is equal to z minus vt, meaning it has to be linear in z and t. So if this is the kind of form that we see, then we can say that it is a wave and it satisfies this equation. Then we can say that the F represents a wave. And since it is given by z minus vt, so if you look at time t equals to 0, if our function is sum at z equals to z1, and at time t equals to t1, the function is at z equals to vt1. That is means it is moving in positive direction of z. So we call this kind of wave as a forward moving waves. Similarly, there will also be a solution that satisfies the same wave equation, which is given by z plus vt. In that case, if at time equals to t0, our wave is at z equals to z1, then at time t equals to t1, the wave at z equals to minus vt1. That is, it is moving at in this direction. So z equals to minus vt1. So this kind of wave is known as backward propagating wave. And these are both the solution of this wave equation, since both positive value of v and negative value of v will satisfy these equations. So even the linear combination of this form, like z minus vt and z plus vt, they are also form a wave. So, but generally, if you have seen in your classwork before, the wave is represented in the form of some like equals to E naught cosine of kz minus omega t. This form. From where this form came, this form is came from Fourier series. It says that if we have any periodic functions, then we can always write it in the form of cosines and sine. So if you look at your function, it seems like it is a periodic function which is moving with some period. Like after this period, it will come here and it is repeating. So if you take this one as a whole, as a function, then we can always write it in sine and cosine form. So if we just talk about just one simple, like if we have just one simple lump, then we can always write a one of these. And if there are combination of these, then there will be a summation term. So we're just talking about one packet here and we just see how it will propagate. Based on that, we will say that the wave is propagating in this direction or something like that. So instead of dealing with whole the combination of these waves, we are just deal with a single lump here. So our functions is basically is of this form. Function f equals to a cos kz minus vt, or we can all multiply k inside kvt. So if we write kv as omega, then it will become kz minus omega t. And a is the amplitude. Here in electric form, we can say that is the amplitude of electric field. And delta is the phase. It will just introduce, for example, if your wave at z equals to 0 has some kind of value, it is not 0. So in that case, you can always calculate what is the initial phase of your wave. But generally, when we solve questions, then this initial wave is not of that much importance. It is just the phase difference between two uh, two positions, like at Z1, at Z2, the phase difference that is really matter. The initial phase does not matter most of the cases. So in one of the property of this electromagnetic wave is that it is transverse in nature, meaning if you take a string and you just take up and down, then the displacement that is introduced in it, it is in the perpendicular to this moving direction. For example, your wave is moving in z direction, but your displacement is in the perpendicular direction. So x is perpendicular to z. So that means that your displacement is perpendicular to your propagation direction. If your wave has this kind of form, then this is known as transverse wave. There is also a kind of wave which is known as longitudinal, which is found in case of like spring. If you take a spring and you just stretch it, then the displacement created is in the same direction in which it is propagated. So this kind of wave are known as longitudinal wave, but we are not dealing with the longitudinal wave here. We are only talking about transverse wave because electromagnetic waves are transverse in nature and the light is also the electromagnetic wave. So basically light is just the high intensity of this light is directly proportional to amplitude mod E square. So whenever we talk about the light, we are generally talk about the electric fields. So there are two perpendicular directions that are possible for the case of propagation. For example, if your light is propagating in Z direction, there are two other directions as well, X and Y, that are possible, which will be perpendicular. So our wave can be have can move in X direction. It could also move in Y direction. Or and for if you take this XY plane as some sort of sheet, then Z is also perpendicular to the XY plane whole. So our wave can also be perpendicular to any other point in this XY plane. So the direction in which the light is moving, it can be xy or any point in xy if our wave is propagating in z direction. So the perpendicular directions will have different form, different direction point. So generally, instead of saying that we are moving in x cap direction, y cap direction, we generally say it is moving in n cap direction, and that n cap could be perpendicular to any plane point in this plane which is perpendicular to this propagating direction. And this x cap is known as the vibration direction or the polarization direction of our wave. And the plane that is being created by this propagation direction z and the vibration direction y. This is known as vibration plane. This is also known as polarization plane as well. So our electric field has component which is E naught is amplitude cos kz minus omega t. This will tell you what is the propagation direction and the direction s cap, which will tell you the polarization direction. So whenever you see electric field is written something like this form, you can just analyze what is the propagation direction, what is the polarization direction, and what's the amplitude of it. So one of the property that I have told you is the transverse nature, which says that the polarization direction always going to be perpendicular to your propagating direction. That means their dot product always going to be zero. This is an important property that is generally used when we solve the gate problem. So if we can also write this n cap in terms of theta 1. For example, if it make an angle theta with x direction, we can write it as cos theta in s cap and sin theta in y cap. And also, instead of writing z cap, we can write simple k cap direction. That will tell you the k vector divided by mod of k. So that will tell you the direction in which the any general direction in which wave is propagating. For example, if you take this wave which is propagating in z, there will be case that it will propagate at some angle with z. In that case, you cannot write n cap dot z cap. You have to write this one form. So this is most generalized form of this transverse nature of electromagnetic waves. So how can we visualize it? We can visualize it using, for example, a string example. When we take a string and up and down it, we can see that the wave is propagating in this string. And for the case of linearly polarization direction, the point that is in which the string is moving, it is in x direction. So if you take any point, it will be moving in like this, only in x direction, positive x or negative direction. So if our your point is moving in just one along one line, then it is known as linearly polarized line. That line could be along x, it could be along y, or it could be along at any angle. So as long as your string is moving along a line, it will be linearly polarized or plane polarized light because it will make a plane with your propagating direction. So there is also the case of circular polarization. So if you take your string and you start rotating in at the circumference of circle, then it and you start observing it by standing here, like you are standing in front, then what you see is the circular polarization of light because each point of your string is more than moving circular part. So here the electric field that we represent is in linear part and it is generally represented by E0 cos kz minus omega t in the n cap direction. the direction in which the line is. This is the direction along which this your string is moving. So n cap is this line direction. But here in this case, you have both component, x component as well as y component. So both these components will be form a circular polarization. So your electric field here is the combination of x component cos kz minus omega t and y component sin kz minus omega t. The important point here to note is that for a electric field to represent a circular polarization, your electric field Ex and Ey, they have to have a phase difference of pi by 2. So these two component is expected. For example, here it is E0 cos kz minus omega t, and the y polarization has can be written as E0 cos kz minus omega t minus pi by 2. So if there is a phase difference of pi by 2 between Ex component and Ey component, and their amplitude is also same, in that case it will represent a circular polarization. With the amplitude has to be same because to be a circle, your radius has to be same in x and y direction. So your Ex component, Ey component will form a circular equation. So we will solve the questions based on this concept of circular polarization. I hope it is clear to you. And what I mean by Ex and Ey component is your electric field is a linear combination of this Ex and Ey component. So if Ex component is this plus Ey component is this. If your amplitude is not same, for example, Ex0 is not same as E by 0, then your circular polarization have different radius in x direction and y direction, and that will lead to elliptical polarization. So even if the phase difference between two is pi by 2, but your amplitude is different, it will be elliptical polarizations. It will not be circular polarization. And also, if there is another phase, like it is not neither 0 nor pi by 2, but it is something else like pi by 3 or pi by 4. That case is also come inside this elliptical polarization case. So elliptical polarization is more general, and when phase, for example, if your electric field is given by A cos kz minus omega t, and your Ey is given by B cos kz minus phi. If phi is 0, that will lead to linear polarization. And if phi is pi by 2 and A equals to B, that will lead to circular polarization. If phi is something else, anything could be like 0 or multiple of 2 pi or 4 pi, so that cosine will not change. Or it will be multiple of pi by 2, then and it is something else like pi by 3, then it will be elliptical polarization. So elliptical polarization, so this is most general form of equation. Now come to this. As I have told you, if both are cosines, that will lead to linear polarizations. For example, if your electric field is such that is given by E0 is cos z minus omega t and E2 given by E1 is the Ex component and E2 is the Ey component. So we can just write it. It is given by cos kz minus omega t plus 2 pi. So we already know that if there is something cos 2 pi plus 5, we can always write this as cos pi. There is a positive sign. So this term is already E0y and Ex. So we have already E0x and E0y. So the resultant electric field is the linear combination of E1 and E2. So if we take this E0x cos kz minus omega t in the x cap direction, E0y cos kz minus omega t in the y cap direction, the phase phi will get changed by this identity. And now if we use this identity, cos x plus y equals to cos x cos y minus plus sin x sin y, if we use that and we take this term out, the term in x cap, actually I have changed my notation. I cap here is just same as x cap and j cap here is same as y cap. sorry, I have just changed my notation. I have used I cap and J cap here. So this will be E0 x cos kz minus omega t in the x cap. But if you open this concept, cos kz minus omega t plus 2 pi. So again, this term will become 0. So they are just try to show this identity to you. So the final electric field is E0 s in the I cap direction, E0 y in the j cap, cos kz minus omega t. So your final electric field has amplitude which is depend on this vector sum, but your cos kz minus omega t form, this form is correspond to the linear polarization. So if you take two component of electric field in x and y direction and both have cosine component, then it will lead to linear polarization with the resultant amplitude given by this vector sum. You can calculate it from here. Cos 2 pi is 1 and the resultant phase that it resultant angle that this linear polarization make with x and y axis is given by this 3 tan inverse E0 y by E0 x. For example, let's consider a very simple case. For example, I have take this very simple case in which I take my E0 x as 1 volt per meter and E0 y as also 1 volt per meter. In that case, my electric field E, which is given as E1 vector plus E2 vector. So basically, I have E0 x in the I x cap or I cap, E0 y in the j cap, and cos kz minus omega t. So if you look at this E1 component, this will represent the electric field in x direction. So your electric field, this is y, this is z, is in x direction. And according to this E2, electric field is in y direction. This is the resultant. But if you take the combination of that, then your electric field will be in z dot, not in z. It will make an angle which is given by phi, which is tan inverse E0 y E0 1 is 1. That means 45 degree. So your resultant electric field make an angle 45 degree. If this is x and this is y, it will make an angle 45 degrees with this both x and y. But it still is remain the linearly polarized light because it is moving in this direction. So this is basically the concept, what it means when we have different phase values. Now come to this another concept, let's say how we can visualize circular polarizations. In this case, let's say I will start with this thing. My electric field E1 is E0 cos kz minus omega t. So in the x cap direction. So I will take E0 as some number, let's say 4. And E2 is given by again 4 because it's necessary condition that amplitude has to be same for circular, but another term in y has to be for 90-degree phase difference in the y cap. Now how we visualize it? Our electric field E1 is in the x cap direction. So this is x, this is y, and this is z. So E1 is in the x cap direction. EY is in the y cap direction. This E2 component, it is in y direction. And the resultant component E vector is the combination of that. And to visualize it, what we do is we start with, let's say, at z equals to 0. How the electric field E1 is 4 cos omega t. And the electric field E2 is minus 4 sin omega t. I have just put z equals to 0 here. So this is my electric field look like. Now, if time t is equals to omega t is equals to 0, electric field E1 has amplitude 4 and E2 has 0. So at time t equals to 0, my electric field is in x direction. resultant E, which is E1 plus E2. So this is an X cap or this is an Y cap. So my resultant field at t equals to 0, it will be is in 4 in the X cap direction. So this is my resultant. Now if my omega t is equals to 0, if I increase my omega t to pi by 2, let's say time get increased, how the field will evolve? Omega t will become pi by 2, this term will become 0, and our field will become minus the 4 in y cap. So if this is my y, this is z, so then my field go to minus 4 in minus y cap. So with time, my field get evolved and it move from plus 4 to minus 4. And if I completely draw it, then it will become a circle and it is like clockwise direction. So this is how we find how our electric field is evolving in different cases. So we will start with solving questions based on GATE examination and then we will see different concept here. If you have any doubt, you can ask. Is everything clear till here?
Yes,
Okay,
ma'am.
I will start.
Ma'am, can you explain circular polarization?
In case of circular polarizations, there are two conditions that has to be satisfied. One is that amplitude has to be same, both x and y component. See, if for the circular polarizations to exist, let's start with this basic. The circular polarization will have both components, x and y. Only then it will make a complete circle. And the component x and y has to have the amplitude which is equal. If Ex component has E0, then Ey also has to be E0. Otherwise, your radius in X will become different from Y and it will become more of a elliptical shape. So your Ex and Ey has to have same amplitude. And second condition is that the phase between X and Y, it has to be pi by 2. That is, if our Ex is A0 cos kz minus omega t, then our Ey should be A0 cos kz minus omega t minus pi by 2, or which can also be written as E0 sin kz minus omega t. So Ex and Ey supposed to have a phase difference of pi by 2, only then the circular polarization exists. And the best way to visualize this circular polarization is we put the z equals to 0 in our equation. We put z equals to 0 and we see how with time the things will evolve. Then I equals to 0. I have taken omega t completely. It makes it easier. Otherwise, you have to deal with omega, which generally not given just to see the visualization. Because if time increases, omega t increases obviously. So with omega t equals to 0, we have electric field component and which is only one component exists, cosine component, and with omega t equals to pi by 2, only sine component. So but just by so only just by checking at two position, omega t equals to 0 and omega t equals to pi by 2, we see that our electric field at omega t is in x cap direction. You can draw an arrow in x cap and it has a amplitude 4. So the arrow is according to this. At omega t equals to pi by 2, the electric field is in. This component will become 0 and only this component survive, minus 4. So you can draw again an arrow with minus 4. And you can see with time t equals to 0 to t equals to pi by 2, this is how your field move. So by just extrapolating it further, we can say that the field is moving in clockwise direction. So this is how we see the circular polarization. So is it clear?
Yes, ma'am.
Okay, now we start with solving the questions. There there is this question in GATE 2019, question number 14. The electric field of an electromagnetic wave is given by 3 sin kz minus omega t in x cap plus 4 cos kz minus omega t in y cap. Now we have two components here. One is the Ex, which is the x cap component. Another one is Ey, which is in y cap direction. Now the wave is, we have to answer whether the wave is a linearly polarized, elliptically polarized, or with some angle. If it is linearly polarized, what is the angle? And if it is elliptically polarized, is whether it is moving clockwise direction or it is in counterclockwise direction. So we will solve the problem exactly the same way as we did for the circular polarization. So we are given an electric field with 3 sin kx minus omega t and cos kz minus omega t. Now you see the Ex and Ey component. They have a phase difference of pi by 2. One component is cosine and another is sine. So there will be no chance that it will be linearly polarized. For a linear polarization, phase should not be a multiple of pi by 2. Either it will be 0 or a multiple of pi. So it is not a linear polarization because for 0 and 1 pi case, in that case, their both component are cosine. So for linear polarization, both component has to be cosine. Circular polarization, amplitude has to be same. So amplitude is different. So it is also not a circular polarization. Now we have elliptical polarization. But there are two cases possible. Either it move in counterclockwise or clockwise directions. Now to check this, we just put z equals to 0 in this and we are left with Ex component which is minus 3 sin omega t and Ey component 4 cos omega t. Now we check with at omega t equals to 0, what is the condition? At omega t, Ex is 0, only Ey is equals to 4. So at omega t, we have this component Ey survive. As the time increases, omega t become pi by 2, Ex will become minus 3, and Ey will become 0. That is, it is moving in this direction and it is to minus 3 with time. So with time, it is moving in this direction. So if you look at this direction, this is counterclockwise direction. So the right answer is D. It is an electrically polarized light in counterclockwise direction when seen towards the traveling towards the observer. If you are standing, minus z direction, which is away from the observer, then you are just like you are looking at this clock from behind and you see opposite direction. So you will need take care of the question in the question where it is asked towards the observer or away from the observer. So basically, generally, when they say towards the observer, that will talk about positive z direction. And when we talk about away from the observer, that is talk about negative z direction. So in question, this part is also take care. I hope you will get it. Now next question is again in GATE 2019. So in a set of n successive polarizer, the mth polarizer make an angle m by 2n with the vertical. So we are given that we have n successive polarizer, means we have one polarizer, then we have another polarizer, another polarizer, and the mth polarizer, if we are talking about, it will make an angle n pi 2n with respect to initial light waves. If it is like vertically polarized light is incident onto this first polarizer. For example, if we talk about the third polarizer, so it will make an angle 3 pi by 2n with respect to the initial incident light. A vertically polarized light beam of intensity I naught is incident on two such sets. We have two sets. Similar like this one, we have another one set here. So we have two sets of polarizer and they are both differ in case of numbers. So one have number n1, another one n2. N2 is greater than n1. That means second set have more number of polarizer compared to the first set. Now let the intensity of light beam coming out of the first after first case is IN1, after second case of IN2. So with this collection of polarization, we have pass over light. and the intensity is In1 after first case, and after second case it is In2. We have to find which of the option is correct. In2 is greater than In1, the polarization is vertical, or In2 is less than In1, polarization is vertical, or it is horizontal, means which one intensity is less. Since it is a case of polarizer, so we are going to use Malus law. We say that the light, if we have two polarizer, and it makes an angle theta with respect to one another. In that case, the intensity pass through after this polarization, after this polarizer bundle will be I naught cos square theta t. Actually, if you have a one polarizer and you have linearly polarized light, it is same as having two polarizer combination and unpolarized light. Because after passing through one polarizer, it will make a linearly polarized light and the concept will become like this. So we are going to use this equation I equals to I naught cos square theta. And they are making an angle theta m, which is m pi by 2n. So if you look, apply this formula after n polarizer, then for example, after first polarizer, it will be I naught cos square theta, and after second polarizer, it will be cos square theta multiplied by this term again. So you will have, cos square theta and then power 2n, like this concept. I will show you later. Now, first answer this question. What is the polarization of the final light after coming through this combination? Now, if you look at this Malus law, it says that final light will be I square cos theta, and theta will be m pi by 2n. In case of first polarization, in case of first case, where we have n equals to n1, after whole polarization, this thing m will become n1 because m means mth polarizer. So after passing through whole the polarizer, m is become n1. In that case, theta will become, these two quantity will become equal, and theta will become pi by 2. So even in the case when m is n1, or in the case when m is n2, theta will be pi by 2. That means intensity will become 0. So if we have vertical light, then the output light is horizontal. That is, it will not going to pass through it, only that intensity will be 0. So our final output will be horizontal light. Now we have to see whether pa- through the second is larger than the first, or the intensity passed through the first is larger than the second. For this, we just take a very simple case. Let's fix our M. I have just suggested a hit and try method here. Just fix our M to 1. Then our intensity will become I naught cos m pi by 2 by n1. I have used m equals to 1 here. And the intensity is the multiplication of all these terms. Now we are given that n2 is greater than n1. So let us consider the case n2 is equals to 2 times of n1. So if I take n1 to be 1, then n2 to be 2. So the intensity I1 will become I naught cos pi by 2 since n1 is 1. So I1 will become 0 in that case, and I2 will become cos, here cos pi by 2 by 2 square. 2 multiplied by n2 I have taken 2. So it is 4. So intensity I2 will become I naught by 2 square, or 0.25 times of I naught. So in this case, if I take m is equals to 1 and this condition, then my intensity I2 will become 1. Now let us consider that n1 is 2 and n2 is 4. Since I have taken that n2 is 2 and 1. In that case, intensity I1 is 0.25 I naught, and I2 will become by the same formula 0.53 I naught. So in this case, I2 is again comes to be I1. So if you try that case, most of the time I2 is always going to be greater than I1. So your I2 is going to be greater than I1 and polarization is horizontal. So this is the right answer. So basically you have to fix the parameter one by one, and in the formula you are given the two parameter for the theta and pi by 2n. So first fix n, change your n. Then you will be able to see how the trend is going with respect to the intensity in two cases. And based on that, you will find the right answer. So, okay, let's move to the next concept. I hope it is clear to you. The question is coming in GATE 2018 examination. A quarter wave plate introduces a path difference of lambda by 2 between the two components of polarization parallel and perpendicular to the optic axis. An electromagnetic wave is given a component S cap plus Y cap E naught to the power I k z minus omega t is incident normally on a quarter wave plate, which has its optic axis making an angle 135 degrees with the x-axis. The emergent electromagnetic wave would be elliptically polarized, circularly polarized, linearly polarized, with polarization as incident wave, or linearly polarized with polarization at 90 degrees to the incident wave. So what we are given is we are given an electromagnetic wave which is basically Ex and Ey component is given to us, and it is incident normally to quarter wave plate. So basically what quarter wave plate is kind of birefringent material, and what it does is it's change the phase difference between the two components of electric field. So if you have incident combination of Ex and Ey and you pass it with quarter wave plate, then it will introduce a phase difference in either in X or in Y with a phase difference phi of pi by 2. I'll show you from where pi by 2 came. But quarter wave plate introduces a phase difference of pi by 2 in either in X or in Y. So between Ex and Ey, the phase difference is get increases. Now it is says that it is the optic axis of this quarter wave plate which make an angle 135 degree. So first what we have to do is we have to see the quarter wave plate is given according to their path difference. It is given that it gives a path difference of lambda by 4, and therefore phase difference which is given by 2 pi by lambda multiplied by path difference. So if you do this 2 pi by lambda multiplied by path difference, which is lambda by 4, it will give you pi by 2. So the phase difference that is introduced by quarter wave plate is pi by 2. Next, what you have to do is you have incident electric field. You have to break it in component along the optic axis and perpendicular to the optic axis. Because the phase difference is introduced as per the axis of this optic axis. So initially my electric field is given by this form. We can write in the more real component which we are familiar with. So we can write E0x, which is the EX component, as E0. For example, here I can also write it like E0 I kz minus omega t in the x cap plus E0 I kz minus omega t in the y cap. So this term e the power I kz minus omega t is a complex form, and real form can be written like this. So Ex component is E0 cos kz minus omega t, and Ey component is this. So if you look at your amplitude is same, cosine and cosine both Ex and Ey. So that means in initial polarization of incident wave is linear polarization. So after passing through quarter wave plate, first thing happen is Ex component break into two components. So one is along the optic axis and one is perpendicular to the optic axis. So the one along the optic axis is E0x cos 45 cos 135, and perpendicular to that is E0y Sine 45. But it is E0x
Ma'am, what is E0Y?
sine 135. E0y,
Yeah.
actually they are same. E0x is E0. It is given in question. E0y is E0. They are both same. Means in question it is given. So I just write it more general form. So they are E0x and E0y. They are the x and y component. Okay, sorry. E0x, actually I haven't taught you this thing. Can I explain you again
Ma'am, where is the sign
more
come?
clearly? See, it is given to you in question that electric field is given by x cap plus y cap E0 e to the power I k z minus omega t. And this is the complex form. And you are aware that you can, if you have e to the power I some function IKS, you can write it
Cos theta plus I sin
cos
theta.
kx plus I sin kx. So this is real part. Is this same thing. So this is imaginary part. So just to either you can solve in this form if you are comfortable with this, or you can transform into this linear form. Just to take only the real component and solve the equation. What will give you same answer? I have just taken the real component. So I just take E0 cos kz minus omega t. I just take it inside bracket. And that E0x is the x component of that. And E0y is the y component of that. Are you able to get it? How I
Yes.
transfer
Yes.
from this to this? Okay. So this is the linear polarization. I just take it so that it will simplify my problem. Otherwise, you can solve in this complex form. That is also fine.
Okay.
Okay. So after passing through the quarter wave plate, my electric field E0x will become E0x cos 135 since it quarter wave plate optic axis make an angle 135 with the x direction and therefore perpendicular it make an angle 40. This is y, this is x. If it make an angle 135 with x, then it will make an angle 135 plus 90 with y. So my E0x component will become E0x cos 135, and since it is a quarter wave plate, it's not simple polarizer. So it will also introduce a phase of 90 degree. So you can either add the phase or you can subtract the phase. Both are equally considered. Just your answer might get differ, but both are correct. So in quarter wave plate, you have to introduce a phase of pi by 2. So your E0x component after passing through quarter wave plate will become cos E0x, this term multiplied by cosine, since it's the cosine component, plus extra phase which is introduced by quarter wave plate. So I started with this. Just forgot about this for the moment. So you are left with E0x cos 135 plus 90 degree. So you can also write it minus E0x sine 135. You are aware with this identity. Cos theta plus 90 is minus sine theta. So this E0x 135 is then become minus E0x by root 2. Similarly, if you look at the E0y component, after passing through this quarter wave plate, nothing will change except that this component will get the sign of 135. See, the phase difference that I have to introduce due to quarter wave plate, I've introduced in one just component in EX. So I just take E0Y as it will not introduce anything in Y. So you can either introduce 90 degree in X component or in Y component. So whatever your suitability. Basically, the phase difference between EX and EY has to be 90. So this phase difference. So I have introduced in EX, so I have introduced EY 0, so this phase difference remain 90 degree. So E0Y component has only the sine component in it, and this is my E0Y after passing to quarter wave plate. So if you look at the E0X dash, it is become minus E0X by root 2, and E0Y dash, it will become E0Y by root 2. Now if you look at E0X, E0Y, they are just multiplied by this term. So my final electric field in x direction will become E0 by root 2, means yeah, there is a multiplication will came due to this quarter wave plate and a negative sign. So since there is a negative sign, that will means the phase that is introduced, which is given by tan inverse yth component, which is E0y by root 2, and x component minus of that. So it will become minus of tan inverse 45 degree. E0x and E0y amplitude is same. So I just cancel out both these two terms. And that will give you phase difference of minus of 1, and that will give you phase difference of minus 45. So initially the light is in 45. Now after passing through quarter wave plate is in minus 45. So the light will remain linearly polarized, but angle either is 180-degree change or it is in the same direction. In my case, it is came to be negative, that is, it is moving 180 degree with respect to initial. But if you use negative sign concept, then you will get this positive term, and you will get that your light will move in the same direction. So if you look at the option is given for linear polarization. There is no option for 180 degree. There is option for 90 degree and in the same direction. So the only same direction is correct. If there is an option with 180 degree, that is also correct. Do you have any doubt in this question?
No, ma'am.
Ma'am, that one concept is there about optic axis. So
Yes,
you mean to say that we have to take the component in the direction of optic axis itself, right, ma'am?
yes, because the quarter wave plate, yes, because the quarter wave plate, what it does is, if you have a quarter wave plate and it has an optic axis direction, and when you
Mm-hmm.
incident an electric field onto it, it will introduce the phase difference along this optic axis direction. So you have to take your component along that direction. Only then you can introduce a phase of 90. If your component is not that direction, the phase will not be 90. It will be something else.
Okay. Okay, ma'am.
Okay. So let's move to next question. This came in GATE 2015, question number 50. So a plane wave is given exactly the same form as the previous question. And after passing through an optical element, it will came out in this form. So what is the that optical element is? So this is my incident wave. This is my output wave. And there is some element that is placed in between them. So what is that element is? So if you look at the EX component, I have again simplified it in cosine form. So this is my X component and this is my Y component. Similarly, in output, this is my X, but Y component has negative. So EY might become minus of E0, which can I which I also write this like cosine of pi, as you are aware with this cos pi plus theta equals to minus cos theta. So with minus, that means the phase difference between EX component, EY component, it is 0 initially. If this is phi 1, this is phi 2, then the phase phi 2 minus phi 1 is 0. But here, if you look at the phase, this phase is phi 1, dash, and this is phi 2 dash, or like this is phi 2 dash. And if you take the phi dash, it will be phi 2 dash minus phi 1, and this is pi. This means the optical element is such that it introduces a phase of pi, and it which from which we can calculate what is the path difference that is introduced by this element by using phase equals to 2 pi by lambda into path difference, and path difference turns out to be lambda by 2. That means it is a half wave plate. So if you place a half wave plate between an incident wave and between an incident and output wave, it will introduce a phase difference of pi by 2 in any one of the not pi by 2, pi in any one of the components. So here it introduces a phase difference of pi in y component. So it's a half wave. Now this one is come in GATE 2013. It's an easy question. A circularly polarized monochromatic plane wave incident on a dielectric interface at Brewster's angle. Which one of the following statement is correct? So reflected light is plane polarized light in a plane perpendicular to the incident, and transmitted is circularly polarized light. Well, as you are aware with this concept of Brewster's angle, if this is my interface between two medium, with effective index N1 and N2, and this is normal to that medium, and it's make an angle theta. This is an incident light. This is normal. And if my incident light, I make an angle theta with a normal. And if it is unpolarized, it has component in all directions. Then the light that is reflected is plane polarized light with only components which are perpendicular to this plane of incident, that is out of plane. And the light which is transmitted, it will contain both perpendicular as well as the planar component. So it is basically mixture of both components. So the reflected light always going to be plane polarized light, but with component perpendicular to the plane of incidence. And if we have a circular polarization, again reflected light will have plane polarized perpendicular component, but in case of transmitted, it is a circular polarization as well as the linear polarization. And combination of circular plus linear will lead to elliptical polarization. So the light that is transmitted, it will be elliptically polarized. So this option is correct. Reflected light is plane polarized and the transmitted is elliptically polarized light. So these are the questions that is came in past few years on this concept of polarization. So if you have any doubt, you can ask. Or is it clear? Just let
Ma'am,
me know.
the examples were actually good, and these examples are very clear. But one probably out of the way concept I'm asking, it is about the optic axis. I have already been confused
Okay,
always. What is the understanding of optic axis now?
okay. So
Yes,
this
ma'am.
thing, I'll explain you. You are familiar with this concept of polarizer,
Yes, yes, ma'am.
and polarizer also have its own axis, and
Mm-hmm.
based on that, it will, if you have incident light, if it is unpolarized light, it will pass only the component which is aligned this direction, and we say that,
Mm-hmm.
that our light will get linearly polarized. Similarly,
Mm-hmm.
if you have a quarter wave plate, it has its own optic axis. Okay, so what the main function of quarter wave plate is, it will introduce, not quarter wave plate, whatever the wave plate you are talking about. As long as
Mm-hmm.
it is a wave plate, it will introduce a phase difference between two components of electric field. So if you have electric field Ex or Ey, so it will introduce a phase difference between Ex and Ey. And the phase difference that is introduced by them is depend upon the optic axis. The component which is aligned along the optic axis, it will get a phase difference. Like if Ex is my component which is aligned this optic axis, then EX will get a phase difference of 90 degree, but EY would not get that difference. It will pass as it is. So basically the phase difference between two components is 90, but one get ahead of another one.
Okay.
Similarly, there might be chance that EY, it will give a phase difference of 90 to Y component and EX will pass as it is. So that will depend upon what is the direction, means if this concept is given, fast axis or slow axis.
Mm.
So optic axis has two parts. It has fast axis or slow axis. Fast axis means the component which align along the fast axis will get a lead, means it will get 90-degree angle. But for the case of slow axis, that means it will lag by this 90 degrees. So this concept is not coming till now in GATE examination. So I haven't taught this fast and slow. So basically, we are trying to align our component along the direction of optic axis so that we can introduce a phase of 90 or whatever. Because we know that if we are talking about quarter wave plate, we want to introduce 90 degree. But if our axis is not aligned, we don't know whether it introduces a phase difference of 90 or some other value. Because if it is not aligned, it could be anything. Na.
Yes. Okay.
So only just to make the thing simpler, we align it, then we introduce phase, and then we realign in later. And even if all the problem of polarizations, we just basically try to align the axis of incident polarized light either with polarizer or with quarter wave plate optic axis. So basically, we just jump to that domain of optical element. We solve our problem there and then we get back to our real domain. So this is the kind of mindset we have when we try to solve this problem.
Okay. Okay. Thank you, ma'am.
Okay. So is there any other question? Okay. If not, then we will finish today's class.
Okay. Thank you. Thank you so much, ma'am.
Ma'am,
Okay. Yes.
can you give these notes
Actually,
through
I
the
will upload the video link today, and on the video link, there is this YouTube link where we have to upload our video. And I will send these notes on description box of this YouTube link. So you will get it after 6 p.m.
Okay, ma'am.
whenever
Thank
NPTEL update.
Okay, ma'am.
Okay. Thank you. Bye.
Thank you, ma'am. And ma'am, there are other lectures. I could see on the NPTEL website. Some of them had the recording links, but many of them does not have any recording link or update links. So shall those be
Uh,
also be updated on YouTube, ma'am?
yeah, you will get, for example, on different days, you are talking about this live lecture, na?
On the NPTEL link, yes, ma'am. On the NPTEL link, when we open NPTEL Gate Physics, there are
Yes.
the schedule is there. So many of the programs which have already been conducted, many of the classes which have already been conducted, for many of them there is the link. Link is available there. But for most
Yes.
of the lectures, the links are not available, which has already been conducted. The links are not available on YouTube. So would those also be uploaded on YouTube, ma'am?
Yes, all videos are uploaded on YouTube. For example, in my case, all my videos are available on this public view. So you can see
Okay.
all the previous video as well. So similarly, all other videos that are not uploaded till now, they are also available sometime later.
Okay. 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 Okay, ma'am. Okay. Okay. Thank you, ma'am.
Okay, thank you.
Thank you so much.
Thank you, ma'am.